In this chapter, we'll explore the basic mathematics for creating magic squares and Sudoku puzzles. We'll explain number systems such as binary, decimal, and hexadecimal. We'll explain exponentiation. Finally, we'll explain how to manipulate numbers that are not expressed in base 10. Number systems contain a group of symbols. A number system is also referred to as a base. For example, ordinary numbers are called decimal numbers or base 10. The decimal system consists of 10 symbols 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The binary system has two symbols 0 and 1. The hexadecimal system has 16 symbols which are a combination of numerals and letters. The hexadecimal system illustrates one method for creating higher order number system. Exponentiation is a mathematical operation with two numbers, a base and an exponent. It can be written as b exponentiated to the nth power. The superscript n can be referred to as an exponent or an index or a power. We can write the number 1000 as 10 to the third power, which equals 10 times 10 times 10. Similarly, we can write 100 as 10 to the second power, which is equal to 10 times 10. 10 to the first power is equal to 10, and 10 to the 0th power, by convention, is equal to 1. Another way of expressing exponentiation is that the number in the exponent is equal to the number of zeros in the final number. However, we're not limited to using base 10 for representation and exponentiation. We could use 5 to the third as 5 times 5 times 5, which is equal to 125. 5 to the second power is equal to 25. 5 to the first power is equal to 5, and again, by convention, anything to the 0th power is equal to 1. When we're building Sudoku puzzles that are 25 by 25, implicitly we will be using 5 to the third power. If we build a magic square which is 5 by 5, implicitly we'll be using 5 squared, which is equal to 25. We'll combine what we've learned about exponentiation in number systems to manipulate numbers in bases other than base 10. We'll use these manipulations to create magic squares and then use magic squares to create Sudoku puzzles. The first step is to determine which numeric base is used. If we create a 3 by 3 magic square or a 9 by 9 newspaper style Sudoku puzzle, we will use base 3. If we create a 7 by 7 by 7 by 7 magic square or a 49 by 49 Sudoku puzzle, we'll use base 7. In this example, we'll use 5 as the base. We'll start with the number 342 and notice the subscript 5, which indicates that we're working in base 5. This is represented as 3 times 5 exponentiated to the second power plus 4 times 5 exponentiated to the first power plus 2 times 5 exponentiated to the 0th power. This is equivalent to 3 times 25 plus 4 times 5 plus 2 times 1. This is also equal to 97 if we represent the number in base 10. If we took the same number, 342, and represented it in ordinary numbers, we know implicitly that this is equal to 342. But using the same techniques, we can say this is equal to 3 times 10 squared plus 4 times 10 to the first plus 2 times 10 to the 0, or 300 plus 40 plus 2 equals 342. We usually ignore the subscript if it's base 10, but here we express it. We'll use all these techniques when we're creating magic squares and Sudoku puzzles.